So we're going to continue discussing logical equivalences. And in your textbook, there's this theorem 2.1.1, which says that we have the following properties when it comes to logical equivalence. So there's 11 different properties here. Some of them we have already seen. So for example, the commutative law, we saw that these were logically equivalent when we did a truth table, but you also have P or Q is logically equivalent to Q or P. We have associative laws, distributive laws, all of these 1 through 11. These are all rules, and we can use them to help us establish the two statement forms are logically equivalent. So let's look at a problem where we put these rules into use. So let's say we want to use theorem 2.1.1 to verify that not P and Q and P or Q is logically equivalent to P. So to do this, what you're going to do is you're going to work with one side of the logical equivalence. So we're going to work with the left-hand side here. And we're going to use these rules in this table and show that we get that this is identical to P. So let's start by writing down the left-hand side. So look at this first part here. This is negating an and statement. And remember that is De Morgan's law. So let's start by using De Morgan's law here. So when you negate, you distribute the negation. So it'll be not P. It'll be not Q, but then you have to flip. It was an and, so it's going to become an or. And let's go ahead and write down next to it, which rule did we use? We used De Morgan's law. And then, if we look at what we have here, we have not P. Well, that is the double negative law. So if you look back up here, the double negative law says not P is the same thing as P. So this will be logically equivalent to P or not Q. So here we're using the double negative law. So if you look at both of these terms you have, you'll see that they have something in common. They both have P or in them. So we can use the distributive law, which is our third rule, and factor that out. So we're going to pull that out, P or, and then what you're left with is not Q and Q. So not Q and Q. So we use the distributive law here. Distributive law. And then if you look, we had our commutative law, which means that was our first one in our table. I can flip the order, so I'm going to use the commutative law on the parentheses. So I'm going to flip it. It'll be Q and not Q. So this is the commutative law. And finally, well, we're almost done. I have Q and not Q. So if we look up at our rules, that's the negation law. When you have an and, you get a contradiction. So the negation law means that I can replace that with a C. Negation law. This is logically equivalent to P or contradiction. And then when you have something or a contradiction, let's see, that was the identity law. So that's the fourth one. P or contradiction is P. So we're going to use 4. We're going to use the identity law to say that this is logically equivalent to P. And that's what we were trying to show. We got what we wanted on the right-hand side. So another way to show that two statement forms are logically equivalent is using these rules in this table. So you can either show that they're logically equivalent through the truth table or through these rules.